Okay, so I hope you enjoyed your one-day holiday, I guess. Okay, and then so we're meeting today, and then we get into the weekend. How about that? Okay, so our lecture, I was pretty much done with related rates. I was going to show you maybe one more and sneak in a little bit of 3.10. And so next week on Friday is our next exam. Okay, so I'm slightly ahead. I'll do one more related rates, introduce some of 3.9, do a little bit of 3.9, then go ahead and give you the quiz. Okay, so our next exam is the 23rd, a week from today. So as usual, you turn all of this in. Okay. All right, so here we go. I was going to show you 29. So let me show you 29. Okay, gravel is being dumped from a conveyor belt at a rate of 30 cubic feet per minute, and its coarseness is such that it forms a pile in the shape of a cone whose base diameter and height are always equal. So this diameter and this height are always equal. How fast is the height of the pile increasing when the pile is 10 feet high? Okay. So here's the picture. So important data, dV dt, rate of change of volume with respect to time, is 30 cubic feet per minute. Okay. And it said, how fast is the height changing with respect to time? We're finding dH dt. Okay. Now it says the diameter and the height are equal. So if the height is 10 feet, the radius would be 5 feet, right? Diameter equals the height. Right, so I used the formula for the volume of a cone, which is 1/3 pi r squared h. But r is equal to h over 2. Okay, since the height is 2r, r is h over 2. Okay, because it says the diameter and the height are the same. So since 2r is h, 2r is, or h equals 2r, then r is equal to h over 2. Okay, I plugged that in right over here. R is equal to h over 2. So it looks like this, 1/3 pi r, here's r, h over 2 squared h. Clean that up, I have h times h times h. I have h cubed, h squared times another h. And I have pi over 12 because 2 squared is 4. 4 times that 3 gives me 12. So volume equals pi over 12 h cubed. So that's what I want. And now I differentiate. dV dt is equal to 3 times pi over 12 is pi over 4, h squared times dH dt. Now it's just a straight plug-in. They told me dV dt is 30. Okay. In case you're saying, how do you know it's dV dt? You can tell by the units. Feet cubed, that's volume. Minute is time. So it's volume over time, dV dt. 30 goes here. The height they told me was 10. That goes there. See, 10 squared is 100. 100 divided by 4 is 25. So 30 equals 25 pi dH dt. Divide both sides by 25 pi. So 6 over 5 pi is dH dt. So 6 over 5 pi feet per minute. And that's my solution. And if you want a decimal approximation, you can punch it in your calculator or whatever, but I'll just leave it like that. Okay. All right, so I'm done with related rates. Okay, so we have 2 sections left before the test. So I have 3.10 and 3.11. So I have all of next week to finish that. But of course, I'm going to aim to try to finish everything by Wednesday. If I finish everything by Wednesday, then I'll do the usual, let you ask questions on Thursday and then test on Friday. Okay, so I'll start some of 3.10. won't go too long, so I can give you enough time to do the quiz. Right? So 3.10 is on linear approximations and differentials. Okay, that was what, 251, but 252, they have something called the linear approximation or linearization. Okay, they have all these formulas here. Okay, you can put them down. There's nothing wrong with it, but I've got the Melvin Hum version of it, what's a lot better. You already know how to find the equation of the tangent line, right? So here's a function, figure 1 on page 252. The blue is a function. The red is a tangent line, right? L of x is simply the equation of the tangent line, but you write it as a function, which means make it look like y equals mx plus b. That's all. So you can either write this down or learn a new concept. But to me, you already know how to find the equation of the tangent line, right? Remember, I was having you do y minus y1 equals m times x minus x1. Stop. Now we're not going to stop. Okay, just do that little bit of algebra, make it look like y equals mx plus b, write it as a function. So L of x is just that y, which equals mx plus b. So all of this stuff is just going to look like mx plus b. So we're really just finding the equation of the tangent line, but then keep going to make it look like y equals mx plus b and call it L of x. L stands for a line or linearization. Essentially what's happening is we're replacing the curve with a straight line. And you can see if I don't stray away from the point too far, the straight line and the curve are pretty good. Of course, by the time you get way over here or way over here, it's not good. But for a very small region, right, then you could say, okay, if I go along the straight line or if I go along the curve, it's practically the same, which means I can replace the curve with a line. Now, why would I ever want to do that? Straight lines are nice. We know how to handle straight lines. You know, the original function might have all kinds of stuff. It might have exponentials, logs, square roots, cube roots, and trig, and exponential and log. But if I replace it with a straight line, it's a lot better. Okay. So I'm not even going to teach you guys this. So what's this linearization stuff? It's the equation of the tangent line, except written as y equals mx plus b. Instead of y, we write L of x. So I want you to get comfortable with L of x. That means writing it as a function. That's the linearization or linear approximations. Differentials, not really that difficult a concept. Okay, so if I show you page 254, here we are. dy equals f prime of x dx. These are called differentials. Differential dy and dx. They're sometimes called differentials. dy is a tiny change in y. Dx is a tiny change in x. In fact, you can think of dy as delta y, where delta y is pretty small. Dx is like delta x, where delta x is pretty small. Okay. Now, pictorially, this shows you the difference between delta y and dy. Now, delta x and dx are going to be the same, this picture. Delta y is the actual change in the function values. Okay, so if you go along the blue curve, right, this would be delta y. dy is the change if I went along the straight line. So you can see they're not always going to be the same. So if I went along the straight line approximation, the tangent line, the distance from here to here, that's dy. So you can see dy is only an approximation of delta y. But normally it's easier to compute. Sometimes delta y is pretty hard to figure out. Okay, so if you want to put something on your cheat sheet, you can put this. And if you stop and think about it, look at this equation, right? These are both different ways of how to write the derivative. I mean, dy dx means derivative. F prime of x means derivative, right? Okay. Well, what if I multiply both sides by dx? If I multiply this by dx, it's gone. And if I multiply this side by dx, it looks like that. So it's very logical. So you can put it on your cheat sheet or not. I mean, you always go back to this. You say, oh yeah, dy dx means f prime of x. Then just think of multiplying both sides by dx. It looks like this. So dy equals f prime of x dx. Okay, so if I have time, I'll show you some problems here. All right, so those are problems involving differentials. Differential says if I have a tiny change of y, how is that affected by the tiny change of x? You multiply by f prime of x in general. Okay, so let me get you started with that. So here's the Melvin-Hum version of linearization of a function. The equation of the tangent line written as a function, L of x equals mx plus b. So whereas before, we said, oh, give me the equation of the tangent line, y minus y1 equals m times x minus x1, stop. Now go ahead and finish up that algebra, isolate the y, and we'll say L of x is equal to whatever, like negative 3x plus 10. Okay. L of x, the linearization function, is an approximation to the function itself. But you can see it's a straight line. I like straight lines better than all kinds of other stuff. Okay, so now let's get started with sum of 3.10. Okay, so what are we supposed to do? 1 to 33 odd. Okay, so here it is, page 256. Again, for the benefit of those of you that don't have the book and don't plan on getting it. Okay, so there is some of that. And a bit more for the bottom. And let's see, 33 was how far we had to go. Yeah, so there's 33. And there we go. Okay. So 1, 3, 5, find the linearization at the given a value or x value. It's the same as saying find the equation of the tangent line. Okay. 5, of course, skip anything for graphing calculator, but we can still find the linear approximation. Okay. For 7 and 9, verify the given linear approximation. You don't get scared. It's really the same as these problems. This is the back of the book, so to speak. So suppose it said, find the linearization of ln 1 plus x at a equals 0, and the back of the book says x. So they're just saving you the trouble of not having to look in the back of the book. Okay, then after that, there's some differentials. Okay, so we'll see how far I want to go, and then I'll stop after a while and give you the quiz. Okay, so problem 3, f of x equals square root of x at a equals 4. Find the linearization, find the equation of the tangent line. Okay, so first I need the y coordinate. That's easy to plug in, 4, 2. That's the point. Now we need the slope. Slope means derivative. Radical x means x to the 1/2. So the derivative is 1/2 x to the minus 1/2. And that comes out to be 1 over 2 radical x. Okay, now I want the derivative at x equals 4 or a equals 4. Plug in 4. 1 over 2 times 2, 1/4. Okay, and yes, that means on the square root function, which kind of looks like that, right? When x is equal to 4, the slope happens to be 1/4. Okay, y minus y1 equals m times x minus x1. Before I said stop, but now keep going, make it look like y equals mx plus b. So distribute y minus 2 equals 1/4 x minus 1. Add 2 to both sides. So y is now L of x. Okay, so the linearization of x is 1/4 x plus 1. This is an approximation to the square root function, but we're more comfortable with this than this. Okay, it's a lot easier to plug into here. So this is the equation of the tangent line, but written as a function, L of x. By the way, what do you get when you plug in 4 right here? 1 plus 1 is 2. What do you get when you plug in 4 here? 2. It matches exactly. Okay, but we're saying as long as I don't stray too far away from 4, like 4.1 or 3.9, you say, how do I get the square root? You could just plug it in here, and you'd have a pretty good approximation. Okay, and we'll try to show that for something like problem 5 now. Okay, find the linear approximation of square root of 1 minus x. So you can see that's not a very comfortable function, but if I can replace it with a straight line function, it's a lot easier to plug in stuff like this. Okay, so find a linear approximation and use it to approximate square root of 0.9, square root of 0.99. Okay, now we're not supposed to punch these in our calculators. Okay, we're supposed to punch it into the linear approximation. Okay, so how do you do that? All right, so first I plug in 0. When I plug in 0, I get 1. So the point is 0, 1. Okay, they didn't give me that 1, but that's easy. I just plug in. Okay, find the derivative. So remember, this is 1 minus x to the 1/2. Derivatives is 1/2, 1 minus x to the negative 1/2. Then by the chain root times the derivative of the inside, which is negative 1. So clean it up, negative 1 over 2. That means square root of 1 minus x. Okay, now I plug in 0. Negative 1 over 2, radical 1 minus 0, that's 1. So negative 1/2. So y minus y1 equals m, negative 1/2 times x minus 0. Write it as a function, that's easy, just add 1. So y equals L of x is negative 1/2 x plus 1. Okay, now the rest of the problem. They say approximate square root of 0.9, square root of 0.99 by using the linearization, the linear function. Okay, now 0.9, look back at the function. 0.9 is 1 minus 0.1, right? 0.99 is 1 minus 0.01, which means to approximate this, I plug into the linearization 0.1. To approximate the square root of 0.99, I plug in right here 0.01. Okay, that's the way it works because this is the function. Okay, so one more time, 0.9, the square root of 0.9, that's 1 minus 0.1. So I'm going to plug in 0.1 to right here. Likewise, how do I get this? How do I get the stuff underneath the radical, in other words, to be 0.99? I would go 1 minus 0.01. So I would plug in 0.01 right here. Okay, so L of 0.1 is negative 1/2 times 0.1 plus 1. Okay, I plugged in 0.1 right here, comes out to be 0.95. Do the same thing for 0.01. Okay. See, f of 0.01 means I'm taking the square root of 0.99. That's the thing that's a little bit tricky about this. So I plug in 0.01 right here. Negative 1/2 times 0.01 plus 1. Punch it out, 0.995. Okay, so my approximations for the square root of 0.9 is that. And the approximation for the square root of 0.99 is that. Okay, the problem's actually finished, but I'll dig deeper. Okay, so I actually punch out on my calculator square root of 0.9, 0.9487. Look at our approximation. Pretty good. And this is even better. My approximation for the square root of 0.99 was 0.995. On my calculator, I got 0.99499. Very, very close, as you can see. So the approximation did a pretty good job. All right, so that's how to do problems like 1 through 9. So I showed you some of those. Okay, do a few differentials and then I'm done. Find a differential of each function. It's really not hard, folks. You just put dy on this side, then on this side you figure out the derivative and multiply it by dx. Okay, okay, so 11a, y equals x e to the negative 4x. So ordinarily, I would say dy dx equals blah, blah, blah. Well, just multiply both sides by dx, and you have this. Okay, so this looks like a product rule. First, x times the derivative of the second. Derivative of e to the negative 4x is e to the negative 4x times negative 4. Chain rule. Plus second function, e to the negative 4x, times the derivative of the first. Derivative of x is just 1. Okay, so a little bit of touch up. dy is equal to negative 4x e to the negative 4x plus e to the negative 4x dx. Okay. That's all. Then let's see, 13b. I think I'll stop with that. So y equals 1 minus v squared over 1 plus v squared. 13b over here. So dy equals the derivative of all this, dv. So I've already written it, I'm done. Quotient root. Bottom, 1 plus v squared, times the derivative of the top. Derivative of the top is negative 2v. Minus the top, 1 minus v squared, times the derivative of the bottom, which is 2v. All over 1 plus v squared squared. Okay, then just some cleanup. So I distributed. So that's negative 2v minus 2v cubed minus 2v minus a minus of plus 2v cubed. 2v cubes cancel out. So my final answer, dy negative 4v over 1 plus v squared squared dv. And there we go. Okay, so I was going to stop there. So I showed you a couple of linearization problems, and I showed you a couple of differential problems. I'll do more on Monday and continue from there. Okay, so time-wise, again, I still have more of 10 and 11. I'm going to aim to try to finish everything by Wednesday. Questions and answers Thursday. Friday is the quiz. Okay. All right, so I'll stop there. Let me check the chat to see if there's anything else, and then I'll give you the quiz if not. Okay, so see nothing in the chat. And nobody's asking anything. Okay, so here comes the quiz. Get your cameras out. As usual, Prasanna and I will come around and see if anybody needs any help. Okay, and then I'll put you in your breakout rooms. Okay, so let me blab a little bit longer while I'm setting everything up. So after I set you up in your breakout rooms, yes, you are allowed to leave. I might put you in a different breakout room. If your breakout room ends up having only 1 or 2, be ready for me to push you to a different room. And again, if you finish, it's not due until what, 12:10 on Monday. But again, if you submit it early and something isn't right, I have a chance to help you fix it. But if you submit it like at 12:05 on Monday, I'll take it, but I won't have an opportunity to help you fix it, so to speak. Okay. So just I wanted to warn you about that. Okay. So let me try to share the screen again. Get your cameras ready. All right, there we go. So take a picture. I'll blab about it. Okay, a projectile is launched into the air. The height in meters after t seconds. And by the way, all of these should have the proper units. Okay, proper units. So what are the proper units of velocity? What is the proper units of acceleration? Okay, so the height is y equals negative 4.9 t squared plus 19.6 t. Okay, so 6 questions. What is the velocity of the projectile just as it lifts off the ground? When does the projectile reach the maximum height? What is the maximum height? When does the projectile hit the ground? What is the velocity of the projectile as it hits the ground? And what is the acceleration of the projectile? Okay, so we've talked before about velocity. Velocity is your first derivative. Acceleration is your second derivative. Make sure you have the right units. So they give us meters. So velocity is meters per second. Acceleration is meters per second squared, and so on. Okay. All right, I think everybody's got it. So go ahead and get started. Let me set up your breakout rooms. Okay, you should have an invitation to join your breakout room. So everybody please go to your breakout room now. Everybody who hasn't joined, please join your breakout room. Let's see. So Prasanna, looks like some people already ditched or took off or whatever, so. Okay. Okay, let's see. Noman, Juries, and Mega, can you please join your breakout room? Okay, let's see.
Professor,
Yes, Mela?
I didn't take a picture of the quiz. Can you get the quiz again so I can take a picture?
Okay, I've got to put some people in rooms, so you'll have to wait a moment, sorry.
Sure.
Okay, some of you still haven't joined your breakout room, please join. Okay, Malak, I think I can get it. Give me some time. Okay, so there it is. Malak, tell me when you have it so I can get rid of it.
I got it. Thank you.
Okay, all right, thank you.